Hello everyone, myself Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical, Engineering, Dundigal, Hyderabad. Today, I am going to discuss about a concept of Newton's law of cooling. What is the Newton's law of cooling? Which formula we apply in Newton's law of cooling? So I want to discuss about the topic of Newton's law of cooling in detail in this video. Main concept of Newton's law of cooling we want to discuss here. So, statement. What is statement of Newton's law of cooling? The rate of change of temperature of a body is proportional to the difference of the temperature of the body and that of surrounding medium. The rate of change of temperature of the body is proportional to the difference between the temperature of the body and that of temperature of the surrounding medium. This is the statement of Newton's law of cooling. With the help of this statement, we will prove here one formula. With the help of the formula, we solve the problems based on Newton's law of cooling. So one time again, we want to repeat the statement of Newton's law of cooling. The rate of change of temperature of the body is proportional to the difference of the temperature of the body and the temperature of the surrounding medium. So now, proof of formula, very important formula and very interesting formula for Newton's law of cooling. We will prove in this video, in this lecture, Newton's law of cooling, formula for Newton's law of cooling. So here proof, start proof. That is very interesting formula, which will be very useful to solve the problems. Let theta be the temperature of the body at any time t. At any time t, we see that the body of the temperature is theta, and theta naught be the temperature of the surrounding medium. That medium where the body is kept. Usually, medium is known as air. Body always be putting in air medium. Every place where you put the body, there air is present, except liquid. Not liquid there, only air. So by Newton's law of cooling, we have, according to statement of the Newton's law of cooling, rate in change in the temperature of the body. Rate in change in means between two times. What is the change in the temperature of the body? So here we are considering this d theta. D theta is the change, the temperature of the body, and dt is the difference between two times. Suppose here this is time t naught, temperature is theta, and here is theta, t, time is t, and temperature is theta plus d theta, delta theta. So change in temperature, theta plus d theta, del theta minus theta, upon change in time, t minus t naught. So this is delta theta upon delta t, or t plus, here t and here t plus delta t. So t plus, here t plus delta t minus t. This is static. This is last time. This is first time. Last time minus first time. Rate in change in time. Rate in change in temperature. So rate in change in temperature with respect to time. That is del theta over dt. Basically, we can say this is very minimum time. So delta t tends to 0 here. Then del theta over del t. This is known as a d theta over dt. Change in temperature of the body with respect to t. So d theta over dt means rate in change in temperature of the body. So d theta over dt is the rate in change in of the body. Is proportional to, this is the difference between the temperature of the body and the temperature of the air medium. So here theta is the temperature of the body and theta naught is temperature of the air medium. So d theta dt is proportional to theta minus theta naught. This is equation 1. According to statement, we have written this equation 1. Rate in change in the temperature of the body proportional to the difference between the temperature of the body and at the temperature of the surrounding medium. So always the temperature of the body is greater than the temperature of the medium. So a difference between the temperature of the body and minus temperature of the surrounding medium. Theta naught is the surrounding medium, temperature of surrounding medium. Usually we take air medium. So this implies that d theta over dt equal to, here is equal sign. This is equal to minus k theta minus theta naught. Minus k is here. This is equation 2. Where k is positive constant, k is proportional constant. We are taking here k is proportional constant, and proportional constant is always a positive. Negative sign, we have taken here negative sign. Here is also wrong. This equal to minus k. This is wrong. D theta over dt, this equal to minus k. This equation 2. Minus k. We have taken here minus sign. Negative sign is taken because time increase, the temperature decrease. Time increase, then the temperature of the body is decrease. So we get here negative sign. This one. D theta over dt equal to minus k theta minus theta naught. This is the differential equation of the first order and first degree. This equation 2 is known as a differential equation of first order and first degree. And method used to solve the equation 2, variables are separable. Variables are separable. This method we can apply in equation 2 to find the value of theta. Theta is the temperature of the body. So here d theta, writing here d theta upon theta minus theta naught equal to minus k dt. This is total function of theta, and this is the function of t. This is equation 3. Integrating 3 on both sides. So this implied that integration d theta upon theta minus theta naught equal to integration minus k dt. Here apply formula integration 1 upon x dx equal to log x plus log c. C is an arbitrary constant. So integration here 1 upon x dx equal to apply formula log x. So similarly in first integral we apply d theta upon theta minus theta naught. This is x, this is dx. Or we can say here 1 upon theta and d theta integration is log theta. But theta naught is constant. Theta naught is always constant because this is the temperature of the surrounding medium. So here we apply this formula. So after integrating, we get log theta minus theta naught. Log theta minus theta naught equal to minus k dt. Integration only dt. Dt means t. So here minus kt plus log c. Log c is arbitrary constant. C is an arbitrary constant. This implies that log theta minus theta naught equal to, here is minus kt. Minus kt, we can write this equal to log e to the power minus kt. Minus kt equal to log e to the power minus kt. So this formula apply here. Log e to the power minus kt plus log c. Here apply formula log a plus log b. Log ab. We apply formula here log a, log x plus log y. This equal to formula log xy. So we multiply c and e to the power minus kt. Multiply each other. Log is common. So log is common, c e to the power minus kt. And this side is log theta minus theta naught. So log h cancel out on both sides. Then we get theta minus theta naught equal to c e to the power minus kt. Now theta naught taking to right hand side because theta naught is constant, c is arbitrary constant, k is proportional constant. T is time and theta is temperature of the body at any time t. So finally we get formula theta equal to theta naught plus c e to the power minus kt. This formula gives temperature of the body at any time t. With the help of this formula we can find the temperature of the body if time is given. Any time is given, then we can find temperature of the body. Okay. So now we want to solve problem 1 based on Newton's law of cooling with the help of above formula which we have proved just now. Theta equal to theta naught plus c e to the power minus kt. Formula is theta equal to theta naught plus c e to the power minus kt. This is the formula for Newton's law of cooling. So we want to solve problem 1 based on Newton's law of cooling. What is problem? Problem is this, given in our question paper. Then how we can solve this problem? So I want to discuss here problem 1 based on Newton's law of cooling. A body kept in air medium with temperature 25 degree centigrade. This is the temperature of the air medium. That is theta naught. Theta naught is the temperature of the air medium. So that is 25 degree. Cool from 140 degree centigrade to 80 degree centigrade. The temperature of our body will be cool from 140 degree to 80 degree within 20 minutes. In 20 minutes. Okay. Find when the body cool down to 35 degree centigrade. Find the body cool down, find the temperature of the body cool down to 35 degree centigrade. Find the time. Here is time. Find the time. Also find what will the temperature of the body after 40 minutes. So here we find time. Find time. Here is time. In our problem is time. Find time when the body cool down to 35 degrees centigrade. This is one problem. Next problem, also find what will the temperature of the body after 40 minutes from the original. Again, I want to read the problem. What is problem? Problem is this: a body kept in air medium with temperature 25 degrees centigrade, and the temperature of the body cool from 140 degrees centigrade to 80 degrees centigrade within 20 minutes. So find the time when the body cool down to 35 degrees centigrade. 140 to 35 degrees centigrade. 140 to 80 degrees centigrade cool down within 20 minutes. So how many time taken to cool down up to 35 minutes? 35 degrees centigrade. Find what will be the temperature of the body after 40 minutes from the original temperature. So start solution. Very interesting question this. Let theta be the temperature of the body at any time t. Theta is the temperature of the body at any time t. And theta naught be the temperature of the surrounding medium. Theta naught is the surrounding medium. Theta is the temperature of the body at any time. Time is t. Basically, at starting we have three components. One component is theta of the body. Theta is the temperature of the body at the time t. At that time, theta naught is the temperature of the surrounding medium where body is kept. So next, now Newton's law of cooling, we have a proof of a formula. Just in this lecture, first we have proved a formula. That formula is known as a Newton's law of cooling formula. That is very famous formula. So formula is this: theta equal to theta naught plus c e to the power minus kt. That is represented by equation 1. Theta equal to theta naught plus c e to the power minus kt. Theta is the temperature of the body. Theta naught is the temperature of the air medium. And c is the integration constant e to the power minus kt. K is the proportional constant and t is the time when the temperature of the body is theta. So this is formula we have proved. Now using this formula in this problem. So given us that, what value given us in our question? First is question theta naught. Theta naught is air medium temperature. That is 25 degrees centigrade. And when the body kept in the air medium, then time is t0. Starting time is 0. So T equal to 0 here. Then temperature of the body is 140 degrees centigrade. When the time is 0, then temperature is 140 degrees centigrade. Temperature of the air medium is 25 degree. And temperature of the body is 140 degrees centigrade. And time is when the body kept in the air medium, that is T equal to 0. These value putting in formula number 1. Putting values from equation 2 in equation 1, then we get. Equation 1 is our formula. Equation 2 is the values given in our problem. So, this is the formula 1. Theta equal to theta naught plus C e to the power minus kt. Here theta is 140 degrees centigrade. Theta naught is 25 degrees centigrade. And plus C. C is the integration constant. We have to find the value of C. And e to the power minus kt. T is 0 here. So minus k into 0. E to the power minus k into 0. This equal to 1. So here 140 degrees centigrade equal to 25 degrees centigrade plus C. C into 1 is C. This implied that C equal to this 0.25 degrees centigrade taking to left side. Then this convert into negative sign. So C equal to 140 degrees centigrade minus 25 degrees centigrade equal to 115 degrees centigrade. This is the value of integration constant. C is 115 degrees centigrade. This is the value of integration constant first. Now, putting the value of integration constant in given formula. 1. Putting value of C equal to 115 degrees centigrade in given Newton's law of cooling formula. Then we get theta equal to theta naught plus, this is the value of C, 115 degrees centigrade e to the power minus kt, this equation 3. Now again, theta naught is 25 degrees centigrade. Then equation 3 becomes theta naught always 25. That is constant. No change in the temperature of the air medium. So we put here theta naught is 25 degrees centigrade. Then theta equal to 25 degrees centigrade plus 115 e to the power minus kt, this equation 4. Now, the temperature of our body cool down 140 to 80 within 20 minutes. When T is 20 minutes, then theta cool down to 80 degrees centigrade. So T is 20 degree, then theta is 80 degree. Now again putting in equation 4, these two values, T is 20 degree. In first result is T is 0. Then theta is 140 degree. T is 0, theta is 140 degree. Then we find out the value of arbitrary constant, integration constant. And after putting integration constant in equation 1, then we get the value of theta again. So now next condition, when our temperature of our body cool down up to 80, then T is 20 minutes. After putting these values, theta is 80 degrees centigrade equal to 25 degrees centigrade, 115 e to the power minus kt. This is kt. T is here 20. Putting T is here 20 degrees centigrade, 20. Next, this one. So, we find out the value of e to the power minus 20k. So, this equal to this 25 taking this side and dividing by 115. Then we get e to the power minus 20k equal to 80 degrees centigrade minus 25 degrees centigrade and divide by this 115 like this. 115 e to the power minus k20 e to the power minus 20k equal to 80 degree minus 25 degree. Now e to the power minus 20k equal to 80 minus 25, this is 55 degree upon 115 degree centigrade. So this result here, e to the power minus 20k equal to 80 degree centigrade minus 25 degree centigrade upon 115 degree centigrade. This is also degree centigrade. And next, difference of 80 minus 25, 55 degree centigrade. Divide by 115 degree centigrade. After dividing this, divide by 11. 11 5 ja 55. 11 5 10 ja 5 2 ja 10, 5 3 ja 15. So this is 11 upon 23. This implied that e to the power minus 20k equal to 11 by 23. This equation 6, very important this result. E to the power minus 20k equal to 11 by 23. This is 6. When theta is 35, cool down up to 35, then what is time? Which time the temperature of our body cool down 35 degrees centigrade? We have to find here time. So we have to find here time t for theta equal to 35 degrees centigrade in equation 4 again. So here is 35 degrees centigrade and equal to 25 degree plus 115 e to the power minus kt. T is unknown here. T is unknown here. T we have to find. So e to the power minus kt equal to 35 degree minus 25 degree centigrade upon 115 equal to 10 upon 115. So we have here e to the power minus kt equal to 10 upon 115. This is equation 7. Now this one. We can write here kt e to the power minus 20k, multiply here 20 and divide by 20. We can write this e to the power minus kt, multiply 20 and divide by 20. This equal to 10 upon 115. So now we can write this e to the power minus 20k whole to the power t upon 20. This is e to the power kt only. 20 cancel. So here we can write this type. This result is apply in our question. In our question is apply. We have here e to the power minus kt. So here e to the power minus kt multiply 20 and divide by 20. This equal to e to the power minus 20k whole to the power t upon 20. If powers of power, then multiply the powers. So 20 cancel. This is same result is this. Okay. We can write this result here. So here I am writing this e to the power minus 20k whole to the power t by 20. After multiply this power, 20 cancel. This is same result is this. Same result. This is equation 8. But we know that e की power minus 20k is 11 upon 23 from equation 6. We have last proved this. E to the power minus kt is this. E to the power minus 20k is 11 by 23. This value putting here. So putting, but we know that e की power minus 20k is 11 by 23 from 6. From 8 we have this result putting in 8. So 11 by 23 whole to the power t by 20 equal to 10 upon 115. This is 9 equation. Taking log on both sides to find t. Log on both sides. So here log of 11 by 22, 23 whole to the power t by 20 equal to log 10 by 115. So now power comes before log. So t upon 20 and log 11 upon 115 equal to log 10 upon 115. Okay. So now this goes to denominator to this. T upon 20 log 10 upon 115 upon log 11 upon 115. And t is equal to 20 into log 10 upon 115 and upon log 11 upon 115. Okay. After solving this values with the help of calculator, then we can find value of t. So now t upon 20 log 11 by 23. This is the power. Power comes before log. We apply this formula. Log m to the power n equal to n log m. We apply this formula here. This power comes before log. So here log 10 by 115. This implied that t upon 20 and this goes in denominator log 10 upon 115 upon log 11 upon 23. So finally t equal to 20 multiply log 10 upon 115 upon log 11 upon 23. Okay. Here 11 upon 23, right? This is wrong. 11 upon 23. So this is 11 upon 23. Okay, this is correct. So here log 11 upon 23 equal to log 10 upon this. This implied that t upon 20 equal to log 10 upon 115 upon log 11 upon 23. Now cross multiply this. So t equal to 20 into log 10 upon 115 upon log 11 upon 23. After solving this result with the help of calci, then we find this minute. T equal to here 66.22 minute. This is the time. At this time, the body temperature of the body cooled down up to 35 degree centigrade. Therefore, at t equal to 66.22 minute, the theta cooled down up to 35 degrees centigrade. Okay. Now, we have to find the temperature of the body after 40 minutes. What is the temperature of the body after 40? This is 66.22 degrees centigrade. 66.22 minutes. Temperature cooled down up to 35 degree. But now, after timing 40 minutes, what is the temperature of the body? So again, we apply here theta equal to, this is the temperature of the air. This is the value of C, e to the power minus kt. This is the equation 3. We have again taking this equation. Theta equal to 25 plus 115 e to the power minus kt. This is kt. So here multiply 20. Kt multiply by 20. T is 40. Putting here t equal to 40 this. Theta equal to, this is cancel here. This theta equal to 25 plus 115 e to the power minus k into 40. And this equal to 25 plus 115. Writing this result, e to the power minus 40k. We can write this e to the power minus 20k ka whole square. multiply this power to this, 22 ja 40k. Powers of power we multiply in power. So we can write here e to the power minus 20k whole square. Same, I am writing here 25 plus 115 e to the power minus 20k ka whole square. E to the power minus 20k ka whole square. This is e to the power minus 40k. So here 0 is wrong. So now t upon 20, t equal to 25 plus 115 e to the power minus 40k and equal to 25 plus 115 e to the power minus 40k. I am writing the e to the power minus 20k ka whole square. This is whole square. This is equal to e to the power minus, multiply this to this, minus 20k into 2. This e to the power minus 40k. So this is equation 10. Now, but we know that e to the power minus 20k is equal to 11 by 23. This is equation 6. Putting this value, e to the power minus 20k equal to 11 by 23, putting in 10. Then we get theta equal to 25 plus 115 and e to the power minus 20k is 11 by 23 ka whole square. This equal to 25 plus 115, squaring this 11 ka square 121 and 23 ka square 429. 23 ka square 3 3 ja 9, 3 2 ja 6, 2 6 ja 2 3 ja 6, 2 2 ja 4. So here 9, 2 and 5. This is the square of 23. 5 to 9. Okay. So now after solving this, we get 51.30 degrees centigrade temperature. This is the value of theta. So after 40 minutes, the temperature of our body cooled down up to 51.30 degrees centigrade. But when the temperature cooled down up to 35, then time taken is 66.22 minutes. So this is the two points in our problem which we have to find here. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.